In this tutorial, we will look at how to use stoichiometry tables to understand the progress of chemical reactions on the molecular level. Let's look at the reaction that forms ammonia from its element. 3 molecules of hydrogen gas will react with 1 molecule of nitrogen gas to form 2 molecules of ammonia gas. Assume we start with 20 molecules of hydrogen and 10 molecules of nitrogen. The diagram on this slide shows what this would look like on the molecular level. Here we are using white circles to represent hydrogen atoms and blue circles to represent nitrogen atoms. The box on the left shows the reactants, 20 hydrogen molecules and 10 nitrogen molecules. The box on the right shows the product molecules at this point. Initially, we have only reactants and no products. The recipe for the reaction says to take 3 molecules of hydrogen and 1 molecule of nitrogen to make 2 molecules of ammonia. If we do this once, the following results. Notice that we are Xing out 3 hydrogen molecules and 1 nitrogen molecule. When these react, they disappear from the reactants box and are converted to 2 molecules of ammonia in the products box. We can represent this change with a stoichiometry table. We have rows for initial, change, and new. We started with 20 molecules of hydrogen, 10 molecules of nitrogen, and no molecules of ammonia. In this first step, we lose 3 molecules of hydrogen, which is represented in the change row of the table as -3. Similarly, we lose 1 molecule of nitrogen. Since we gain 2 molecules of ammonia, we represent this as a +2 under the ammonia column. The new row shows how the change affects the situation and is just the initial plus the change. Thus, after step 1, we have 17 molecules of hydrogen left, 9 molecules of nitrogen, and we have formed 2 molecules of ammonia. We can also represent this change with a graph. The y-axis shows the number of each type of molecule, and the x-axis shows the progress of the reaction as a series of time steps. The amount of each reactant is decreasing as the reaction proceeds, and the amount of the product increases. Notice that the slopes for the reactant lines are negative, while the product line has a positive slope. If we allow the reaction to go a step further, we get the following. This picture shows the reaction after 2 steps and the corresponding stoichiometry table. At this point in the reaction, 6 molecules of hydrogen gas have reacted with 2 molecules of nitrogen gas to form 4 molecules of ammonia gas. There are 14 molecules of hydrogen left, 8 molecules of nitrogen, and 4 molecules of ammonia have been produced. We can also show this graphically. Notice that each reaction step reduces the amount of reactants by multiples of their coefficients in the balanced chemical equation, and increases the amount of product by a multiple of its coefficient. In this case, since there is a coefficient of 3 for hydrogen, we can use -3x as the change for hydrogen. The change for nitrogen is represented as -x, and the change for ammonia is represented as +2x. Notice that we use minus signs for the reactants because their amounts are decreasing as the reaction proceeds, and positive signs for the products because their amounts are increasing. The new row is the sum of the initial and change as before. By using x's, we can represent the situation at any time step by changing the value of x. The tables we have shown in this tutorial can also be done using moles of reactants and products rather than individual molecules. Using this general strategy to set up stoichiometry problems is very helpful in Chem 51 to follow the progress of reactions, which is the study of kinetics, and to determine the equilibrium positions of reactions that don't go to completion. Click on the next activity in the Canvas module to see this strategy applied to moles of reactants and products.